Welcome to IGCSE Hub, a Discord community server where students they come in to learn, to study, self-study, group study, personal studies, and also to have online classes with experienced teachers. Trust me, this IGCSE Hub is where every student should be. Okay, it has currently has the following subjects on A-level AS Information Technology, Cambridge AS A-level Chemistry, Cambridge AS A-level Physics. And for IGCSE we have ICT, we have math, physics, chemistry. So it's important that every student come into this IGCSE hub and then join in, share with your friends. The link is right here in the description. Trust me, you don't want to miss anything. It's right here, all loaded for you. So join in and study and have a very good result.
Welcome once again to this YouTube channel. In this particular video, we're going to be answering questions from the October-November 2023 variant 41. Now, this is a recent paper and it could be really helpful for the upcoming May-June IGCSE chemistry exams. So let's dive in straight into answering the questions. Okay, so the first question, we have a list of gases shown. And the question says, answer the following questions using only the gases from the list. It's very good that you read the instructions. So each gas may be used once, more than once, or not at all. So the first question there says, which of them causes acid rain? So we simply scroll all the way to the list of gases that we're given. You see that we have sulfur dioxide in the option. Okay, remember that in the chemistry of the environment, only the oxides of sulfur and oxides of nitrogen are likely to cause acid rain. So we'll just simply write sulfur dioxide as the answer here. Okay, so moving forward, which of them forms an alkaline solution when dissolved in water? For any compound to form an alkaline solution, that compound must be basic. So if you look at the list of gases there, you see that ammonia is a basic compound, so it's likely to form an alkaline solution when it is dissolved in water. The next one says, which of them is inert? Now, inert gases are majorly the noble gases. All right, and if you look at all the list of options given, you see that xenon fits into that description. So xenon is a non-reactive or inert gas. Which of them is a product of photosynthesis? Now, photosynthesis is the process by which green plants manufacture their food, in the presence of sunlight and chlorophyll. And two major products are formed, glucose and oxygen. So oxygen is given in the option as a gas, so we simply fill in oxygen as the answer to this. All right, the next question says, which of them can form a polymer? Now, we know polymers are simply formed from either addition polymerization or condensation polymerization. All right, and ethene or the alkenes generally are addition polymers because they form addition polymers because they could combine to form a single product. So in this particular answer, ethene is a monomer, okay, that can be added in several units to form a polymer. Which of the gases is produced in the test for nitrate ions? Now, when you're testing for nitrate ions, we usually use aqueous sodium hydroxide and aluminium foil. And when we use these two substances, we are going to produce a gas, ammonia, okay, which can then be tested using a damp red litmus paper. So when you're testing for nitrate ions, you produce ammonia gas, which can then be tested using a damp red litmus. Okay, so when it gives a positive test, it should tell you that yes, it contains ammonia and it also contains nitrate ions. So that is for the first question. So let's go into the second question. The second question says boron and aluminium are group 3 elements. Boron has only two naturally occurring isotopes, boron 10 and boron 11. Right, so complete table 2.1 to show the numbers of protons, neutrons, and electrons in the atom of boron 11. Now, if you check the periodic table, you know that boron has an atomic number of 5, or the proton number. So you could just consult the periodic table at the end of the page of this exam. So remember that the number of protons is the same thing as the number of as the atomic number. So the number of protons for boron is 5. And because boron is a neutral atom, the number of protons is equivalent to the number of electrons. So it has 5 electrons equally. Now, for us to get the number of neutrons, remember that the mass number of neutrons is simply the mass number minus proton number. So mass number minus proton number. Right, now you do that deduction, it's simply going to be 11 minus 5, which is 6. So 11 minus 5, and that is 6 neutrons. So 6 neutrons are present there. Now the next question says that the relative atomic mass of boron to one decimal place is 10.8. Determine the relative abundance of boron 10 present in boron. Okay, abundance of boron 10, yeah, present in boron. Give your answer as a percentage. Now you can recall that the relative atomic mass is the percentage abundance. So I'm just going to try and write the formula here. So the RAM, which is the relative atomic mass, is simply the percentage abundance of the first isotope multiplied by the mass of the first isotope. So mass of isotope 1 plus the percentage abundance of the second isotope over 100, okay, which is like the percentage times the mass of the second isotope. All right, so mass of the second isotope. But in this case, we are given the relative atomic mass already in the question, so we need to work backwards to find the relative of the relative abundance or percentage abundance of the isotope. So we'll simply do, since we know the relative atomic mass of boron, so that's 10.8 equal to the percentage abundance of the first isotope is unknown, so we can represent this as x over 100 multiplied by the mass of the first isotope is 10 plus. Now, for us to get the percentage abundance or relative abundance of the second isotope, it will be 100% minus the unknown, which is x, all over 100, times the percentage, the mass rather, of the second isotope, which is 11. All right? So we're going to solve this mathematically. Remember, so when you want to solve this, it's 10.8 equals to 10 times x is 10x over 100 plus, so on 11 is going to multiply everything here, so it becomes 1100 minus 11x all over 100. So we solve this as a fraction. Now when you solve this as a fraction, we're going to have 10.8 equals to, the denominator is 100, so by the time you solve it as a fraction, you have 10x plus 1100 minus 11x. So from this point, you could cross multiply. So by the time we cross multiply, we have 1080 equals to 10x plus 1100 minus 11x. You can collect like terms here. So 1080 minus 1100 equals to 10x minus 11x. So we deduct this, we have minus 20 equals to minus x, and then you divide by minus 1. So minus 1 caters for this negative, and we have 20% as the answer to that question. Okay, so moving forward, use the relative atomic mass of boron to calculate the number of atoms in 0.50 gram of boron. Give your answer in standard form. All right, what formula relates number of atoms? Okay, how do we get the number of atoms? Remember that the number of moles is equal to the number of atoms divided by Avogadro's constant, which is 6.02 times 10 to the power 23. All right, so number of atoms is unknown, and we do not have the number of moles, but we have the mass, so we could get the number of moles. Now recall that the number of moles is the mass divided by the molar mass. All right, so number of moles is, we have the mass to be 0.540, And the molar mass given, remember it says use the relative atomic mass, so it's 10.8. So let's compute that. 0.540 divided by 10.8, that's 0.05, so N is 0.05 moles. So now that we have the number of moles, we can go back to the formula to insert that in to find the number of atoms. So we're going to have 6.02 to the power 23 times 0.05. So by the time you do that, I simply have 3.01. The answer needs to be in standard form times 10 to the power 22 of atoms. So that is that for that question. All right, so moving forward, we have this question on aluminium. Okay, aluminium is extracted from its purified ore. Name the ore of aluminium. Okay, the ore of aluminium is bauxite. So we have bauxite, or you could say aluminium oxide, right? So bauxite. The electrolyte contains aluminium oxide and one other substance. Name the other substance and explain why it is used. So the other substance is cryolite. And the explanation to why cryolite is added is you could either write to reduce the operating temperature, or you could write to improve conductivity. Okay, to improve conductivity. That's the reason why cryolite is added. Either of the two options are okay. You could either write it to reduce the operating temperature of the process or to improve conductivity. Now write the ionic half equation for the reaction at the cathode. You know that the cathode, the aluminium ion moves to the cathode, so we are going to have Al3 plus ion plus gaining an electron, because gaining of electron occurs at the cathode, and we have the aluminium, metal, kind of. Okay, so we do not have to use the state symbols in this case, so I'll just simply erase this. And then, it needs to be balanced in terms of atoms and charge. So I just simply include a 3 here, and we're good to go. Explain why the anodes need frequent replacements. Now, in the electrolysis of aluminium oxide, find out that oxygen is deposited at the anode. And because we are using carbon electrodes, this oxygen reacts with the carbon electrodes to produce carbon dioxide that goes off as a gas. And that's the reason why you need to keep on replacing the anode. So we could simply write that the oxygen is deposited at the anode. Oxygen is deposited at the anode. Okay, it's deposited at the carbon anode. Oxygen is deposited at the carbon anode, full stop. This reacts to produce carbon dioxide. This reacts to produce carbon dioxide. Okay, so the carbon dioxide goes off as a gas, and you need to replace the anode. Two physical properties of aluminium that make it suitable for use in overhead electrical cables. Now, aluminium has low density. Now, you need to be careful with this concept of low density. Do not write light in weight. Okay, light in weight is not a very good reason why aluminium is used. Rather, use the word low density. Okay, another reason why it is used is because it's a good conductor. It's a good conductor of electricity. So it's a good conductor of electricity, and it can be used in overhead electrical cables. All right, moving forward, explain the apparent unreactivity of aluminium. Now, aluminium forms an oxide layer. Aluminium forms an oxide layer which is unreactive. All right, so that's for that. Now, aluminium reacts with fluorine to form aluminium fluoride, which is an ionic compound. Yes, write the symbol equation for this reaction. So we have aluminium plus, the fluorine to form AlF3. Then we need to balance this. So this is this and this. So we have 2 atoms of aluminium, 6 atoms of fluorine in both ends of the equation. Okay, show the electronic configuration of one aluminium ion and one fluoride ion. Now remember that aluminium has a proton number of 13. So the configuration is 283. And then fluorine has proton number of 9, so it's 27. All right, so aluminium is simply going to be donating 3 electrons, losing 3 electrons, and then, okay, these 3 electrons will be gained by 3 fluoride atoms. So for this, we're simply going to have, since we already have 2 electrons already there, so we can simply draw this and complete it with 8. So we are going to first distribute round, so 1, 2, 3, 4, 5, 6, 7, and 8. And we are going to have 3 plus here. And then the fluoride ion, we already have the 2 drawn for us, so we draw the other 7 and then we show it. So 1, 2, 3, 4, 5, 6, 7. And then we show one of the electrons gained by fluoride ion, which is here. Okay, so here we could just write 1 minus, or minus 1, or simply minus as the case may be. All right. So moving forward. Okay, so we have the next question here, trying to look at the order of reactivity. Okay, so we have a list of compounds, and we have metals coming into these compounds. Okay, we have metals coming into these compounds. So we just need to look at it carefully and solve it. So now lead was added to lead 2 nitrate. Of course, nothing is expected to happen because they are the same compound. Now manganese, when manganese was added to lead 2 nitrate, a reaction occurred. Okay, so manganese was able to displace lead in that compound. All right, so let's look at the next question there for silver. Now we added silver to lead 2 nitrate. So we're going to look at it in the reverse order. We're going to see what happens when lead is added to silver nitrate. So when lead is added to silver nitrate, a reaction occurred. So that means lead was more reactive than silver and it displaced it. So if lead can displace silver, there is no way silver will displace lead. So this is off. That is, no reaction will occur. Okay, in case of zinc, what happens when zinc is added to lead 2 nitrate? Now, we look at it in the reverse. What happens when lead is added to zinc nitrate? When lead was added to zinc nitrate, no reaction occurred. So if lead cannot displace zinc, therefore zinc should be able to displace lead. And that is why we have this way. So move to the next row or column. Lead in manganese 2 nitrate. Now let's look at it in the reverse. What happened when manganese was added to lead 2 nitrate? When manganese was added to lead 2 nitrate, a reaction occurred. Therefore, in this case, no reaction will occur. What happens when silver is added to manganese 2 nitrate? Look at it in the reverse. What happened when manganese is added to silver nitrate? A reaction occurred. So in this case, no reaction will occur. What happens when zinc is added to manganese 2 nitrate? In the reverse, when manganese was added to zinc, there was no reaction. That means a reaction here will occur. I move to the last space. What happens when silver is added to zinc nitrate? Now, when zinc was added to silver, we see that a reaction actually occurs. So in this case, no reaction occurs. So now we can, move out, look at the order of reactivity. So we see that in the order of the reactivity, we can clearly see that silver nitrate, was displaced in every reaction. So it makes silver nitrate the least reactive. So silver rather as the least reactive. So silver is the least reactive. Okay, if silver is the least reactive, what else can we observe? We can also observe that zinc could not be displaced by any metal. So zinc remains the most reactive there, followed by manganese. Okay, followed by manganese and followed by lead. So that's the order of reactivity. Now, suggest why the metal nitrates and not the metal sulfates of these 4 metals are used. Now, the metal nitrates are used because all nitrates are soluble. So all nitrates are soluble. Since all nitrates are soluble, they become the most preferred choice. Okay, write the symbol equation for the reaction between zinc and silver nitrate. So symbol equation, we have zinc plus silver nitrate, which is AgNO3. All right, so we have ZnNO3 2 plus Ag. Okay, so we balance the equation. There should be 2 silvers here, so 2 silvers here, 2 nitrogens, 6 oxygens. I think that should be balanced now because just 1 atom of zinc. So that is that. Okay, so next question. Reactivity of group 7 elements can be investigated experimentally. A student bubbles chlorine gas into the test tube containing aqueous potassium bromide. Now remember that chlorine gas is more reactive than the bromine. Based on the periodic table, remember that the reactivity of the group 7 decreases as we go down the group. So there's a very likelihood that chlorine will simply displace bromine from this compound. All right, so, and if it displaces bromine, we're going to have potassium chloride, and bromine gas, will be produced as the other product. So in this case, the reaction, what will be the color change in the test tube? We're going to move from colorless to orange, right? And that's the color of bromine gas that is produced. So complete the ionic equation. So we're going to have Cl2, chlorine gas was added to this, so we're going to have Cl minus, we're going to have Br2. So we balance the equation here, 2 of this, 2 here. So minus 2 charge on both cases, and we're good to go. All right, now the reactivity trend of the group 7 applies to all elements in group 7, okay? The trend, reactivity trend. Use the periodic table to identify the group 7 elements which cannot displace any other group 7 element. So if you consult the periodic table, which we're going to briefly do now, which is at the end of this paper. So you look at the periodic table. Remember I said that the reactivity of the group 7 decreases as we go down the group. So reactivity of group 7 decreases as we go down the group. That means fluorine is the most reactive. So if we go down the group, as far as the group 7s are concerned, you see that tennessine is at the bottom, and that makes it the least reactive. So tennessine will be unable to displace any other halogen. So we simply go and put tennessine as the answer to that question. So I'll simply come right here and fill in tennessine, T-E-N-N, okay, tennessine. I know the symbol as T-S. All right, so we're done with that. So on question 4, aqueous hydrogen peroxide slowly forms water and oxygen at room temperature and pressure. This reaction is catalyzed by manganese 4 oxide. So this is the catalyst for the reaction. State the test for oxygen gas. So the test for oxygen gas is simply the glowing splint test. Glowing splints, and the observation you see is that the splints reignites. Okay, the splints reignites. So that should tell you that the gas is oxygen gas. A student investigates the rate of formation of oxygen gas when manganese 4 oxide is added to aqueous hydrogen peroxide. All right, we have the volume of gas given here. So state how the graph in figure 4.1 shows the rate of reaction at time t2 is lower than at time t1. Now remember that the rate of reaction is fastest at the beginning, and you can see that this curve here is less steep compared to t1. So we'll simply say that at time t2 there is a lower gradient. So there's a lower gradient at t2. Lower gradient at t2. Explain using collision theory why the rate of reaction at time t2 is lower than at time t1. So at time t2, the concentration at time t2, the concentration of H2O2, hydrogen peroxide particles, decreases. Okay, full stop. Therefore, the frequency of collision decreases. Okay, so that is the reason why, that's how to explain using correlation theory. Okay, on figure 4.1, sketch the graph obtained when the experiment is repeated using aqueous hydrogen peroxide at higher temperature. At a higher temperature, you're going to have a kind of steeper curve, but since all other condition remains the same, you're going to produce the same quantity or same volume of gas. So what we're going to do is to sketch something steeper, but when you're sketching something steeper, remember it needs to start from the origin. So we're going to have something like this from the origin, okay, and it must produce the same volume of gas. So it must produce the same volume of gas. So we have a steeper curve that produces the same volume of gas, and that is how to answer that question. All right, so we have a question on stoichiometry. Manganese 4 oxide is added to 20 centimeter cube of aqueous hydrogen peroxide. The total volume of oxygen gas produced is 72 cm cube at RTP. We have the equation of the reaction. So calculate the concentration of aqueous hydrogen peroxide in gram per dm cube. All right, so to calculate the number of moles of oxygen gas produced, remember the relationship is the number of moles of gas equals to the volume of gas divided by 24 dm cube. All right, so but we're given the volume of gas in cm cube to be 72 cm cube. So all we need to do is to convert it, or probably convert the dm cube to cm cube. Remember, the conversion is 1000 cm cube is equivalent to 1 dm cube. So if we convert 24 dm cube to cm cube, we're going to have n equals to 72 cm cube divided by, if you convert 24 to cm cube, I have 24,000 cm cube. So by the time we do that division, we have 72 divided by 24,000, and then we have 0.003 moles. So that is the number of moles of gas produced. All right. Now, determine the number of moles of hydrogen peroxide which reacts. To determine the number of moles of hydrogen peroxide that reacts, we have to use the stoichiometry. So 2:2:1. So we have that of oxygen to be 0.003. Okay, so we're going to compare both of them. Compare hydrogen peroxide to oxygen gas. So the mole ratio is 2:1. So if oxygen is 0.003 and 1 is half of 2, so that means hydrogen peroxide should be double of oxygen. So that's 0.006. Okay, so the next question says, calculate the concentration of aqueous hydrogen peroxide in mole per dm cube. Now, the concentration in mole per dm cube is the number of moles divided by the volume of the solution. All right, we already have the number of moles of hydrogen peroxide calculated right here, and then we have the volume of solution to be 20 centimeter cube. But remember, our answer needs to be in mole per dm cube. So we need to convert the volume to dm cube. So if we have the volume as 20 centimeter cube, we simply divide by 1000. So if we divide 20 by 1000, you have 0.02 dm cube. All right, 0.02 dm cube. So we can then solve for the concentration in mole per dm cube. So it becomes 0.006 divided by 0.02. So by the time we do that division, okay, so 0.006 divided by 0.02. So we have 0.3 mole per dm cube of aqueous hydrogen peroxide. Calculate the concentration of aqueous hydrogen peroxide in gram per dm cube. Now, the concentration in gram per dm cube is equivalent to the concentration in mole per dm cube multiplied by the molar mass of the solution in question. All right. So we already have the concentration in mole per dm cube calculated. So what we need to do is to find the molar mass of hydrogen peroxide. So molar mass of hydrogen peroxide is 1 times 2 plus 16 times 2. So that's about 34. So we're going to have 34, so we're going to have 0.3, so the concentration in gram per dm cube will be equivalent to 0.3 times 34. So if we multiply that, we have our answer to be 10.2 gram per dm cube. All right, so that's for that. Suggest the identity of one other metal oxide which also catalyzes this reaction. Now we know that the catalyst used in the first case was manganese 4 oxide was used as a catalyst. And we already know that transition elements are very good catalysts. So we just pick a transition element such as vanadium. So vanadium 5 oxide, it's a suitable, could be one other catalyst that can catalyze that reaction. Okay, so we go to the next question. Methane reacts with steam to produce hydrogen gas. All right, we have the equation, we have the enthalpy of the reaction, change in enthalpy. So the first question says that the reaction is reversible and reaches an equilibrium in a closed system. So a closed system doesn't allow the escape of reactants and products. So two features of an equilibrium. Number one is that the rate of forward reaction is equal. So rate of forward reaction is equal to the rate of backward. Is equal to the rate. So the rate of forward reaction is equal to, okay, I think I need to write this properly so that we have enough space for the second point. So I'm going to kind of squeeze it in. So I'll write it this way, rate of forward is equal to the rate of backward. So that's the first condition for equilibrium. And the second one is that the concentrations of reactants and products, are constant. Now you need to be careful with this second point. You know, most students make the mistake of saying the concentrations of reactants and products are the same. They are not the same. Okay, they are not changing. So they could have different values of concentration, but the fact remains that they do not change any longer. That is when we can say that they are at equilibrium. So don't use the word they are the same. Okay, use the word they are constant, that is, they are no longer changing. All right. Now the next question says, state and explain in terms of equilibrium what happens to the concentration of hydrogen when the pressure is increased. Now, for us to look at how pressure affects the rate of a gaseous reaction, we have to get the total number of moles of reactant and that of the product. So the moles reacting in this case is 1 plus 1, so a total mole volume of 2 volumes here, and in this case 1 and 3, so total volumes of 4. Okay, now remember that increase in pressure favors the side with lesser volume. So increase in pressure favors the side with lesser volume. So if you increase the pressure, you're going to favor the reactant. Okay, you're going to favor the backward reaction, which is the reactant. All right. So in this case, we are asked what will happen if the pressure is increased. What happens to the concentration of hydrogen when the pressure is increased? Okay, so we could say that equilibrium shifts to the left. Equilibrium shifts to the left. Okay, so when you increase the temperature, equilibrium shifts to the left and favors the side with lesser volume. Equilibrium shifts to the left. Okay, let's write it properly. Equilibrium shifts to the left to favor the side with less volume or lesser volume. Lesser volume resulting in the decrease in the concentration of hydrogen, resulting in the decrease in the concentration of hydrogen. All right, so resulting in the decrease in the concentration of hydrogen. So this is what you need to note about this question. Don't mind the fact that I had to come into the other line to buttress the point. So increase in pressure favors the side with lesser volume. So equilibrium shifts to the left. Okay, that's the first point, and you state the reason why it is shifting to the left. Okay, and then now the next question says, state and explain what happens when the temperature is increased. Now, if you look at, in terms of temperature, what you need to look at is the change in enthalpy of the reaction. So it's an endothermic reaction. So in this case, when the temperature is increased, the equilibrium shifts to the right. So equilibrium shifts to the right. Equilibrium shifts to the right to favor the forward reaction, to favor the forward reaction, since it is exothermic, since it is endothermic. So since it is endothermic, equilibrium will shift to the right to favor the forward reaction. All right, so that is how you go about that question. Okay, so the equilibrium shifts to the right to favor the forward reaction since it is endothermic, and what simply happens is the concentration increases, and the concentration increases. Okay, concentration increases. All right. Now the next one is a catalyst is used. Now we already established that a catalyst does not affect the equilibrium position. So no change, no effect on the equilibrium position, no effect on the equilibrium. Because a catalyst does not affect, the equilibrium position. So a catalyst does not affect the equilibrium position. So that is for that, regarding that. So always know that catalysts do not affect the equilibrium. All right, moving forward, it says name a greenhouse gas found in clean, dry air. Now you have to be careful here because it says methane is a greenhouse gas which contributes to global warming. You've been told about one of the greenhouse gases, and then you have to name a greenhouse gas found in clean, dry air. Because it's dry air, do not mention water vapor. Yes, water vapor is one of the greenhouse gases, but because we are dealing with dry air, rather we'll pick carbon dioxide. Okay, carbon dioxide. All right, so carbon dioxide will be a suitable answer for that question. Explain in terms of thermal energy how greenhouse gases cause global warming. Now, the sun emits thermal energy to the earth. The sun releases thermal energy to the earth. Okay. Now, the sun releases thermal energy to the earth. The earth, on the other hand, reflects the energy. The earth reflects the energy, and greenhouse gases absorb this energy. Greenhouse gases absorb the energy, resulting in global warming. All right, so that is for that. First, the sun releases thermal energy to the earth. The earth then reflects the energy, and the greenhouse gases absorb this energy, resulting in global warming. All right, now question 6. Ethanol is manufactured by two methods: fermentation of aqueous glucose and catalytic addition of steam to an alkene. Method 1 takes place at room temperature and pressure. State two conditions needed in method 1. For the process of fermentation, it takes place in the presence of yeast. So that's the enzyme. There needs to be yeast present, and then it also takes place in the absence of oxygen. All right. Now, the typical temperature and pressure used in method 2, okay, that's the catalytic addition of steam to an alkene. You need a temperature of about 300 degrees Celsius, and you need a pressure of about 6,000 kPa. So you can simply review the conditions for all reactions before going to an exam. That would help you to know the temperatures and pressures. Now, name the alkene used in method 2. Since we are producing ethanol, okay, since we are producing ethanol, the alkene used is ethene. Okay, ethene is the alkene used. State why the reaction in method 2 is referred to as an addition reaction. It's referred to as an addition reaction because only a single product is formed. So in addition reactions, only a single product is formed. Okay, the catalyst in method 2 is phosphoric acid. Dilute phosphoric acid is a weak acid which contains phosphate ions. What is meant by the term acid? An acid is a proton donor. An acid is a proton donor. All right, the meaning of weak in the term weak acid. Okay, weak means it partially dissociates. It partially dissociates. That's the essence of the word weak in that statement. It partially dissociates. Okay, we have to find the oxidation number of phosphorus. So P is the unknown plus oxidation number of oxygen is -2. So 4 multiplied by -2 equals to -3. So P minus 8 equals to -3. So P equals to -3 plus 8, and P equals to +5. So it's +5 right here. One advantage of each method of production of ethanol. For method 1 involving fermentation, we are using a renewable resource. So renewable resource. That's one advantage of the first method. For the second method, which is hydration or catalytic addition of steam, of course, it involves a high rate of reaction, or we can even say we have high purity of ethanol. That is, we can produce ethanol of higher purity. So higher rate of reaction. So you can simply write the higher rate of reaction, or you can write that you obtain a more pure, high level of purity of ethanol. Ethanol can be converted to ethanoic acid by reacting it with an acidified oxidizing agent. Name the acidified oxidizing agent. The oxidizing agent is potassium manganate. So potassium manganate 7. In terms of redox, what type of reagent ethanol is in this reaction? Remember, this is the oxidizing agent, so ethanol becomes the reducing agent. So ethanol is the reducing agent. Ethanoic acid reacts with calcium to form a salt and one other product. Name the salt. Now, whenever ethanoic acid and a metal react to form a salt, so salt is called calcium ethanoate. The formula of the salts, remember, ethanoic acid is CH3COOH, but in terms of an ion, it is this way, donating a proton, and then calcium is calcium 2+. So by the time they interchange their oxidation numbers, you're going to have CH3COO all into 2, and then we have the symbol, which is calcium there. The other product, of course, whenever an acid reacts with a metal, the other product is simply hydrogen. All right, I think that comes to the end of this particular video. So you could watch it and make use of the comment section for any other questions that you have. So thank you for watching.
I want to talk about a very important YouTube channel called Ajiro Tech. Trust me, this YouTube channel is a giveaway. It's loaded with IGCSE. Trust me, is a giveaway. This channel is helpful for your group studies, your personal studies, and it has a proven track record of producing excellent results. So do me a favor, click on the subscribe button, okay, and share this YouTube channel with your friend. Trust me, that will be the best gift that you are giving to them. Thank you very much, and I'll see you in my next video. Bye bye.